Hey, good morning, everyone.
Good morning.
Good morning.
I see everybody that comes to these Zoom meetings. Y'all pretty much have signed on to that quizzes platform, so thank y'all very much for doing that. So far, we've had 9 students sign up, so I appreciate y'all coming on those. We will have a quiz on Friday, so we won't have a Zoom meeting Friday, but you'll have a quiz on this quizzes website on Friday. And it'll cover just the past couple of what we've been doing so far.
Like everything that we've been doing so far.
Just like the past unit, this past unit.
Oh, partitioning. Okay.
Methods, midpoint, partitioning segments, and that's one thing I wanted to go over again today. This is not gonna be very long. It's basically gonna be a review because I noticed there was a couple of questions we didn't get to on the partitioning of segments that I want to make sure you understand how to do. So let me share my screen with everybody that's here. You should be able to see this right now. So it says, given the points of A is -3, 7, so X is -3, Y is 7, and B, 5, -9, X is 5, Y is -9. Find the coordinates of the point P on directed line segment AB that partitions it into a 1:4 ratio. We got to this one last time and we kind of quit because we were kind of running out of time. We've been over an hour by that point. So I wanted to share this one with you. This one, yes. Here is the answer to this, and this is the way it should be done, or this is the easier way it should be done. Same way we were doing it. It's just I wanted to write it all out for you, and I wrote Miss Edwards and I said, hey, how would you do this? I want to make sure we're teaching it the same way. So she sent me this back, and this is the way she does it. So ratio is 1:4. If the ratio is 1:4, that's a total of 5 segments. I hope y'all can see that, but it's a total of 5 segments. Maybe you can see my mouse moving across here because I can't. Let me see. Can I write on the? Yeah, I can. Can I move this? No, I can't. All right, there's our 5 segments right there, 1 to 5. All right, and then these are our coordinates. Okay. And she drew us a graph over here for those. There's our -3, 2 right there. And down here is our 5, -9, okay? And what she did was she took, where do you think she got this 16 and 8 from? Does anybody know?
Mm, 16.
Oh, from adding. Wait, no, just kidding.
Oh, wait. She added, I think she added the 7 and 9 and 5 and 3.
That's right. Yeah, that's the amount of spaces on the y-axis. The 16 is the amount of moves it takes to get from A to B, right? So it takes 16 moves downwards, so a negative direction downwards to get there. And then it takes 8 moves over from A over to get to B, right? So that's just your movement that it takes to get from A to B on your Y and your X axis, rise over run, okay? Rise over run. So what she did there was, which that is very thick line, let me see. And then what she did there from that point was divide by, she wanted to divide that up into 5 segments, right? And so that would give her a new slope of -3.2, 1.6. And that was where I was getting confused the last time. Was like, that's a weird. Did she really put it as 0.2 and 1.6? And according to her, she did. So you move down 3.2, moved from A all the way to B, so moving downward, and then moving over 1.6. So you keep doing that, and it divides it into 5 spaces. Each point is down negative 3.2 and over 1.6. Okay. Now there's another way you can do it as well. After you've confirmed that yes, that will work, okay, and you have your 5-to-1 or 1-to-4 ratio. I'm sorry, 1-to-4 ratio, because there's one right here, and here's the other. 1, 2, 3, 4. You see that?
Mm-hmm.
All right. You can also take, since we're starting at A, you can say, well, where would that partition be if I just added this to my coordinates? And the partition point would be right there. Negative 1.4 and 3.8. And that puts it right there at that point. Okay. All right, let's look at another one that we didn't do as well last time, because I wanted to cover the entire thing. Let's go back to here. And now, given the points, given this one, this was another funky one because it was really short. Given the points -2, 5, and B, 2, 3, find the coordinates of point P on the directed line segment AB that partitions AB in the ratio 3-2. All right, so let me share this portion of my screen, and we'll look at this one. This one was confusing because it was so small. It was extremely difficult to see exactly. Move this. Oh man, put that there, and then I'll just go with black. All right. So it's really small. There wasn't many movements between A and B, and the ratio is 3-2. So 3 plus 2 is 5. So there's going to be a total partitioning of segments of 5 segments. Okay. Now A, she started with A, which was -2 and 5. Okay. Although she put 4 there. Oh, no, she put 4. I think that's a typo. That should be 8. Nope, never mind. I see now. What again was this -2, 4? What is this? Does anybody remember?
Adding the stuff, like adding the 3 to 8.
Yeah.
Wait, no, she subtracted. I think she subtracted it. So.
Yeah, she subtracted 3 from 5. And this thing is not working very well. So that's your Y movement, right? That's going from A to B down on my Y scale, okay? So if I moved from 3 down to 5, or 5 down to 3 is really what it is. 5 down to 3, that's a -2 movement. I'm moving down. And then I went from, on my A-axis, a -2 over to 2, so that's a +4 movement, okay? So -2 to 4, that's a +4 movement. She divided both of those by the number of segments that we wanted. We wanted 5 segments. So you divide those and you get this right here. These are your movements you are going to make on your Y and X axis. And you can see that she did that right there with all those little incremental movements. Now, here's where it gets a little tricky. She took the A and she said, now, where would that partition be from my A point if I just added this particular movement 3 times? And she added 3 times because it's a 3-2 ratio. So you add it 1 time, that gives you a 1 partition move. You add it again, that gives you the 2nd partition move. You add it again, that right there is going to be where your coordinate point is, okay, that partitions that segment into a 3-2 segment. Does that make sense for everybody?
Yeah.
Okay, that's great. That's good. Now let's try one on our own. Let's go back to here. Okay. And let's go to this one. It says, given the points, A is negative half, negative 1, 2, and B is 7, 14. Wow, that's huge. Find the coordinates of the point P on the directed line segment AB. So 7, so we got A is a negative 1, comma 2, and B is 7, 14. Okay. And we're looking for a 1 to 3 ratio. Well, I'm going to go back to I'm going to open up a new program, Paint, and we're going to do it in there. So let me see. I should be able to see this now. And I'm going to pick black size. Go here. Okay. And we're just going to draw this. So we had -1 and then 7. Okay. And we're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 7, 14. Puts it about right there, I think. And then -1, -1, 2. Okay, and we're looking for this. We're looking basically for that segment. Okay, this is A, and this is B, and this is -1, comma 2, and B is 7, 14. Okay, so and it's a ratio of 1 to 3, which is a total of 4 partitions, right? So let's see if we can't do this. So how many moves does it take? This is our y-axis and our x-axis. So y over x. So on our y-axis, how many moves does it take to get from going? So it's -2. So it's right here. So 2 all the way up to 14. That's 12, right? 12 moves, and it's positive, right?
Yeah.
So that's equal to 12. Now for our x, we're going from -1 all the way to 7. So that's 8 moves, right? Okay. So we're going to divide both of those by 4. That's going to be 3, 2, right? That makes sense?
Yeah.
Okay. So we could go from this -1, 2, and we could go up 3 over 2, and that'll get it for us. So we're right here, and we're going to go 1, 2, 3 over 1, 2, and that'll put it right there. 1, 2, 3 over 2, and we would keep going up, and it would partition it. But the other way we could do it, since it's a 1 to 3 ratio, we can take our point right here of -1, 2, -1, comma 2, and add, now this is our x, the 2 is our x, so add 2 and add 3. So that's going to be 1, comma 5. So that partitions to right here. 1, comma 5. And that would partition it into a 1 to 4 segment. And we know that we did that already by counting. There's our 1 to 4. Not the best drawing, but I think you get the point. That you can add your A coordinate point to your new slope ratio that we got over here to get your total new partition point P. Is that clear as mud? Anybody not understand how we got that? All right. Let's go and do a couple of other problems that I got from another teacher to make sure that we understand partitioning even further. Because y'all did pretty well on the line segment. I mean, the graph, writing equations, that was pretty easy for y'all. So let's look at this right here. Point A is at -4 and point B is at 11. So let me see, can I write on this draw? We got 11. And we got -4. And we're trying to get point C, find out where point C is to give us a 1-to-2 ratio. Can anybody do this problem? Tell me what point C will be at. Take your time. Elise, how would you do this problem?
Okay, so anyway, I just know that it's going to be divided into 4 parts because 1 plus 3 is 4.
Wait, where'd you get? Wait, hang on. 1 plus 3. Where did you get the 3?
Wait, isn't that a 3 right there for number 1? Or are we doing number 2 now?
No, we're doing number 1. It's
Okay.
point A. You're reading the same thing, right? Point A is at -4. Point B is at 11. Find a point C that's a 1-to-2 ratio.
Oh, yeah, I'm just having a bit of an issue seeing it, but that's all right. So, yeah, it would be 3 sections.
Yep.
Let's see, and then I'd count the amount of moves right here, because it's not that much.
Yep.
Divide that by 3.
Yep.
Then I'll figure where the point is.
Yep. Okay. So you would count those moves between 4 and 11, right? -4 and 11, and we know that that's 15 moves, right? We would divide that by 3 because that's the ratio of number of moves, and that will give us every 5 clicks there'll be a partition point, right?
Yeah.
Okay. So at 1, if I took 5 and added it to a -4, what will I get? A 1, right?
Yeah.
A 1. So there's my first partition point. And that works the same way on that graph we just did. So there's partition point 1. If I go a little bit farther and add 1, that'll be 6, right? And if I go 6 plus 5 again, that's 11. That gives me right back. So there's our 3. 1, 2, 3 partitions. Okay? And that's all you have to do when it comes to a Cartesian plane or your X and Y coordinate graph, is you would section it off to find out how many partitions and divide. Instead of doing a 1-line segment, which we would call this the X value, we also have to do the same thing for the Y value. Let's try one more. Let's do number 3 here. So point A is way over here at -12, and B is at point 3. And we have a 3-to-2 segment, 3-to-2 segment. So Leslie, I know you're on mute, but if you don't mind, how many partitions will we have?
Sorry, I'm trying to think.
Yeah, no, you're fine.
Sorry, I'm drawing it.
No, you don't have to worry about telling me the answer. You can just tell me how many partitions do we have?
Yeah, no, I'm confused.
Okay, that's fine. Let's get you unconfused here. Who else was Caleb, were you on here?
Yeah, I'm on.
How do you feel? What do you feel about this? Do you know how many partitions we have here at number 3?
5.
5, right. You just added 3 plus 2, right?
Mm-hmm.
Excellent. Now we know we have
I've just been really quiet.
Well, that's fine. And so how many moves are there from a -12 to a 3?
5.
No, there's 15.
Wait,
To go
how?
from point A to point B, right?
Oh, yeah. Yeah.
Yeah,
But
okay.
there would be like, could you just say there's 3 in between there?
Well, there's going to be 5 total partitions between there somewhere, and somewhere is going to be point C. But how do we determine where point A's partition to put point C? How do we do from point A? How do we know? Well, we could take negative 12 and add 5 3 times. Well, 5 times 3 is 15, right? So negative
Yeah.
12. No, that's not going to work. Let me erase that. Let's just count them out and show where it's going to be. Okay, that way we're not confused. So we got to go 5 times. So there's 15 moves. So 1, 2, 3, 4, 5. Here's one partition. 1, 2, 3, 4, 5. Here's another partition. 1, 2, 3, 4, 5. Why didn't that work, guys? What did we do wrong there?
Mr. B, it should be you should get 3 individual like spots, I guess. Because you have to
Instead of
divide
counting
15 by
5, you
5.
should count 3.
So you want to count 3 from
You
5 or from A or B?
from
From
A,
A.
because you would divide 15 by 5. Because it's a 3-to-2 ratio.
Exactly. I was hoping y'all would see that. Good job. So we have to go a little bit further, right? We can't just say 5 faces. We got to say 15 divided by 5, right? Right. That's 3.
So when would you not divide 15 by 5?
You always have to. You take the number of moves from A to B. These are the number of moves. And divide that by the amount of partitions, which is 5. So take the number of moves that you go from A to B, divide it by the number of partitions, and that gives you, right there, we could call that that's the number of spaces or the number of moves to divide it evenly by 5. Okay? The other thing we could do is we could take 3, and we know it's a 3-to-2 ratio. So to find point C, we could just say, well, 3 times 3 is 9. If I take 12 and add it to 9, then I know that I'm going to be at a negative 3, and that will put where my point C will be. My point C will be a negative 3. And how do we know that? Well, let's just count it. And I'll do it in a different color so we can see how this works out. We can say that 1, 11, negative 10, 2, negative 9, 3. There's one partition. Then 1, 2, 3, here's another partition at negative 6. 1, 2, 3, and there's another partition right there. So there's our 3. Here's our 3. We can color them in. That will partition this segment at point C, which is now point C is negative 3. And here's the other 2. Let's change colors again, and we'll put it here. 1, 2, 3 at 0. 1, 2, 3 back at 3 to start. And here is our other 2. So there's our 3-to-2 partition split right there that we needed. So point A to C is from negative 12 all the way to negative 3. And then C to B is negative 3 to 3. Let's try the one below it because it's a little bit, it's the reverse of that. Let's try this one. So now we're at negative 10 and we got to go all the way to 10. So how many spaces is that? How many moves is that, Leslie? This is A here.
Moves between the 10.
Yeah, how many moves is between point A to point B here?
$20?
20, exactly. There's 20 spaces, 20 moves to get from here to here, so 20. Okay, I'm going to write 20 here. Now, Leslie, how many partitions are we going to have to make to find out where point C is going to go? Or how many partitions total? How many total partitions are we going to need to make here?
5.
5, exactly, 5. And now, just like Carla told us a few minutes ago, we take the number of moves, the 20, we divide it by the total number of partitions, 5, and that gives us a total of 4 movements, or 4 movements away to find out where each partition goes. So if I go, let's do it in a different color. Let's try red this time. If I go from -10 here, 9, that'd be 1, 2, 3, 4. So here's partition 1. Okay, 1, 2, 3, 4. There's partition 2. So right there at for C, point C is equal to -2, because that will give us a 2. Here's one partition, 2 partitions. So that solves the 2 part. And then we'll draw it in a different color. This will give us our 3. So then we got to go 1, 2, 3, 4. Here's another partition. 1, 2, 3, 4. Here's another partition. 1, 2, 3, and back to 10. And so here's our 3 partitions. There's our 2 to 3 ratio right there for that line segment. And we know that point C is at -2, which evenly divides that line segment into a 2 to 3 ratio. Does that make sense for everyone? All right, I hope somebody's talking here. Do we have assignments on quiz? You will. I have to assign you don't have one yet. You will on Friday. So Friday. Let's try one more before we go down to the bottom half of this worksheet, if that's all right. I just want to make sure we're all good on learning how to partition a segment. I thought we went over it a little too fast the other day. Let's try one more. So we have this line segment here. Point A is at -9, so here's A. Point B is at 12. That's way over here. Okay. So we want to get from point A to point B. And in the middle somewhere, we're going to divide this segment into a ratio of 2 to 5. So Osas, how many partitions are we going to have?
7.
7, exactly. Carla, how many moves does it take to get from A to B?
21.
21, yes. That's a lot. So there's 21 moves here. So for each, how many moves? You take 21 divided by 7. I wish I knew how to phrase this, but there will be a total of 3 clicks or 3 moves from A to get us to our first partition. So let's change colors. I like that green. That was kind of interesting. So 1, 2, 3 at -6. There is our first partition. Then 1, 2, 3 at -3. There's our second partition. So right there at -3 is where C will be. Okay, and then we can keep going just to make sure we have divided this equally. 1, 2, 3. Here's another partition. 1, 2, 3. Here's another. 1, 2, 3. Here's another. 1, 2, 3. Here's another. And then finally back to here. And we should have 7. Let's count them. 1, 2, 3, 4, 5, 6, 7. Yes. So we know then at point -3, where C is, that it divides this into a 2 to 5 partition. So not too difficult. I think we belabored that point, but I'm hoping you'll start to see how you can do both axes, X and Y, the same way. So let's try this one here. And I'm going to have to zoom in a little bit probably for us to see this. Let's go to 200. Wow, that's good. That's real good. All right, it says that maybe 175. That's better. It says here that point J is on the line segment DE. It lies between D and E such that there's a 2-to-1 ratio. So find point J if D is -2. So let's try this again. D is -2, 1. So D is going to be -2, 1 right there, which is not letting me. Why won't it let me draw on this? Interesting. That really. -2, 1 right there. Okay. So there's D. Point D is right there. And then E is 7, 4. So 7, 1, 2, 3, 4, 5, 6, 7, and up 1, 2, 3, 4. Okay. So we're going to draw this line. Whoa, that's horrible. Undo that. Draw this line here. That's not any better, but I think, man, that's just bad. I wonder if I can just do this. Insert shapes line. You know, I think I'm going to waste more time trying to get this to work right than I'll just. Okay, that's not going to work. We will just leave that there, and I will just draw a horrible scribbly line from there to there. All right, that's better. Now it says find the point segment that D and E such that there is a 2-to-1. So how many segments are we going to have, guys?
3.
3. We got 2 plus 1, right? 2-to-1 ratio gives us 3 segments, 3 partitions. All right. How many X values, or let's start with Y over X. How many Y moves do I have to get to go from D to E?
3.
Just 3? Wow. So I'm at a 1. So 1, 2, 3. Nice. Okay. What about my X?
9.
9. 9? Wow, that's a lot. 9. So our new slope value is we divide both of these by 3. 3 divide by 3 divide by 3. You're going to get 1 over 3. Okay? And that's going to be all positive because we're moving in this direction and that direction. So all positive. So for every one move up, I go 3 over. 1, 2. That's interesting. That don't work right, does it? One move up, then 1, 2, 3. That's good. Then one move up. 1, 2, 3. That should be right there. One move up. 1, 2. Either I haven't drawn this right or something's wrong. I think we're getting the point here that move up 1 and over 3. Up 1 and over 3. 1, 2, 3. Up 1, 1, 2, 3. 1, 2, 3. Okay. So we got a partition here, and then there's the other one. So if we go from D, we just add, say we can say -2, 1. That's D. That's point D. Now if I add these, because this is my X, this is my Y. I add 3 here, and I add the 1 here. Okay. -2 plus 3 is 1, 2. Okay. So point J should be at 1, 2. So 1 and then up here, and there it is. 1, 2. Pretty close to where I had the partition, but still not correct. That is where point J bisects that line, or not bisects, but the partitions into a 2. This will be 1, and then there'll be another 2 over here. I think I just drew this line wrong. And here's another partition, and then there's your final partition.
Wait, but wasn't the ratio 2 to 1, and that would just be 1 to 2?
Oh, you're right. It was 2 to 1. So really, it would push it instead of adding. Yeah. So you're right. It is a 2 to 1 ratio. It still gives us 3 partitions. Let's try. Let's go. That one was very short. Let's too close together. Let's try another one. Why can't I move this down? Let's try here. All right. Let's draw it again. Let's change this to red. All right. It says we got a 1 to 3 ratio, so that's going to be 4 partitions. -7, -4. This will be a little bit wider apart, easier to draw. 1, 2, 3, 4, 5, 6, 7, and down 4. 1, 3, 4. So that'll put us right there. And then 5, 4. 1, 2, 3, 4, 5. 1, 2, 4 right there. Okay. Now we just got to draw this line segment between here. That's pretty good. All right. We got 4 line segments. How many moves is it? How many moves on our x-axis does it take to get from D to E? So y over x. Let's talk about x first. How many moves does it take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 moves on our x-axis. And how many moves on our y? 1, 2, 3, 4, 5, 6, 7, 8 moves on our y. We need to divide those both by 4. Okay. So for our y movement, that's going to be 2. And our 12, that's going to be 3. So every time I move up, I move over 3. So I'm going to change it. I'm going to change it to a different color to show that. Let's go purple. So if I go up 2, 1, 2, I should go over 3. 1, 2, 3. That puts me right there on that point. If I go up 2, 1, 2, I should go over 3. 1, 2, 3. It should put me about right there. Then go up 2. Man, this is not drawn perfectly. 1, 2, and go over 3. 1, 2, 3. It put me there. And then if I go up 2, 1, 2, and then 1, 2, 3, it should put me right back where I've started. And then we'll go ahead and draw our partitioning points. All right. Excuse me. So D. D is at -7, 4. We should just be able to add our 3 to our 7 and our 2 to our 4 to get our new point. Okay. 4 plus 2 is 6. And this will be -7. That's going to be what? -4. Okay. Oh, it's a -4. I'm sorry. Let me erase that. There's something didn't look right. Not a 6. It's going to be a 2. -2. That should be our new point. So let's go make sure we're started here at 0. 1, 2, 3, 4, and down to 1, 2. And yes, it's right on that line. That right there is point J. That is point J. And you can clearly see now that we have one partition here. Okay. And we have partition here, here, and here. That gives us our 1 to 3 partitioning point. And we did all of that by taking point D and adding to this 3 to 2, which we got from right here. Okay. I know there's a lot of steps, a lot of movement in that. Would y'all like to see another one, or do you feel pretty confident how we got to that?
I'm feeling pretty confident.
That's good. That's great, Elise. Leslie, what about you?
Maybe one more.
Okay. All right. Caleb, what about you? How do you feel?
It's not hard. Like I kind of got it. I'll
That's
just
good.
have to remember once you get the slope to like subtract or combine them.
That's right. That's right. Hostas, how do you feel?
Mm, I think I'm fine with it. I think I'm fine.
All right, let's try one more because I want to see how this one, maybe this one will turn out to be a little bit different. So we got our, all right. So let's go ahead and plot point D and point E, -6, 1, 1, 2, 3, 4, 5, 6, -1. That puts it right there. There's point D. E is at 8, 6. So 1, 2, 3, 4, 5, 6, 7, 8, and then up 6. 1, 2, 3, 4, 5, 6. Right here, that puts it at point E. And from there, we just draw a nice straight line, which is not that one. Let me try to do that a little bit better. Okay. This is not the easiest thing to do. All right, that's a pretty good line. All right, now that we have our points, 6, 1, -6, -1, and 8, 6, how many moves? How many partitions are we going to have? Well, 2 plus 5 is 7. So we're going to have 7 partitions. I'll just put partition. 7 parts, basically. And we need to find our y and our x movements because that's basically our slope. So to move up on our y-axis, we're going to do y first. 1, 2, 3, 4, 5, 6, 7 moves. So 7 up on our y. And then our x, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 on our x. We divide both of those by our 7 because that's the amount of parts that we have. Just like we did on our line segment, we got to divide that by the number of partitions we need. That gives us 1/2. Now we could take that and we could take point D and we could add that twice to point D and we will know exactly where point J lies. So let's take -6, comma, -1. Okay, x and y, x, y. So our y goes here, our x goes here. So -1 plus 2 is 1. -6 plus 1 is -5. I got to do it one more time because it's a 2 to 5 ratio. I go 1 and I go 2 here. So that's going to be 2 plus 1 is 3. A weird looking 3.
Is it 1 the y?
Oh, gosh. Yeah. You are so right. Good catch. All right. So 1 and 2. Nice job, Caleb. See, you are getting this. All right, and then that's going to be 0, comma, 6. That'd be -4. And then we'll do it again. That's going to be 1, and that's going to be -2. So our point J should come at -2, comma, 1. -2, comma, 1, and it hits it right there. Hits it right there, which would be our J value. Now, we can check that in a different color. We'll go with this green here. That's nice and good looking. We just got to go up 1/1 or down 1, up 1, I'm sorry, up 1/2, up 1/2, 1, 2. That puts that right there. There's one partition point. We got to go all the way to 7. So up 1/2, up 1/1, 2. There's that other partition point. Well, that's nice because that's the one we calculated, -2, 1. Let's try it again. Up 1/1, 2 puts it right there. we'll keep going. Up 1 over 1, 2, it puts it right there. Up 1 over 1, 2, it puts it right there. Up 1 over 1, 2 right here, and then we're back to our beginning. How many segments is that? 1, 2, 3, 4, 5, 6, 7. And then we could just color them in if we wanted to say here's one segment and here's another segment. And then there's the other 5 segments that are not colored in. And I divided that 2 into 2:5 ratio, with point J being right there at point -2, 1.
I have a question.
Yes.
Okay, so you're subtracting, like, back to when you subtracting it twice because of the ratio, right?
That's exactly right. Yep.
Okay.
Here's another way you could have done it, Leslie. You could have taken E and subtracted this 1:2 ratio, or this right here. You could have subtracted from 0.86. You could have subtracted 1 to 2 5 times, and you would have still got back there, right? Because you would just 1, 2, 3, 4, 5. So since we're going from D, we just have to do it 2 times. If we went from E, we'd have to subtract it 5 times. Does that make sense?
Okay. Yes.
Okay, perfect. And then up here, when we were back here, reason why we only had to subtract it 1 time is because we were a 1:3 ratio. See that? And then up here, we were a 2:1 ratio. So it just depends on how many times the ratio, and you always start, the 1 goes to the D, the 3 goes to the E. Okay, so you can use either point. You just got to make sure that your ratio numbers match up to the point you're looking at. Like this 2 would go to the D, the 5 would go to the E. And you should be good there. So that's partitioning a segment. We'll have a little quiz on that on Friday, along with some other stuff that we're getting into, such as the making sure you'll still understand your midpoint and your distance formula, and writing equations. So other than that, we should be good today. But does anybody have any other questions?
So no quiz today, right?
No quiz today.
Okay.
I will post this little note here on partitioning if anybody wants to keep working. There's a few more down here just to make sure that you understand. And if you can't figure it out, that's when you could send me an email on it. Hey, I don't understand this. All right. All right. Well, y'all have a great day then.
You too.
All right. See y'all later.
too.
You too. Bye.